All right, in this video, I'm going to explain question number 5, question number 6. And again, we are working with exponential expressions that contains parentheses. Like I mentioned in my previous video for questions 1 through 4, when you see an exponential expression containing parentheses, you're going to be working with one of these rules here. Okay, one of the ones that I highlighted in yellow. How do you know which one you're going to be using? It all depends what is happening inside the parentheses. In problem number 5, I see a fraction. Okay, remember fraction is a division problem. So basically we're going to be working with this rule here, the power of a quotient. And basically, let me write down the problem. So we have 24 to the 17th power over 24 to the negative first power, all of that raised to the negative second power. If you look inside, I have two bases, 24 to the 17th power, and I also have 20 on the bottom, 24 to the first power, and then on the outside, we have the negative 2. And according to the power of a quotient, basically what I'm going to do is I'm going to take the top of my fraction, the 24 to the 17th power, and I'm going to raise all of that to the exponent that I highlight in yellow, and it's outside the parenthesis, to the negative second power, over. Now I'm going to do the same thing with the bottom of the fraction, 24 to the negative first power. All of that I'm going to raise to the exponent I highlighted in green, that is outside the parenthesis, and is negative 2 power. Okay, so basically I gave the exponent negative 2 to the top of the fraction and to the bottom of the fraction. That's basically what I did. Now to simplify what I wrote below, if you look inside the parenthesis, I only have one base. So we're going to be applying this rule, the power of a power rule, that basically says when you have a base with an exponent raised to another exponent, you're going to keep the base. I'm working on the top. I'm working with the top of this fraction that I'm highlighting in blue. Okay. I'm going to take the top of that fraction. The base is 24. I'm going to keep it. And what I'm going to do with the two exponents, I'm going to multiply using the calculator. 17 times negative 2 is negative 34. And then I'm going to do the same thing on the bottom. Okay, so I'm going to do this now. So the 24th is my base on the bottom. And I'm going to multiply the two exponent. Negative 1 times negative 2 is positive 2. Okay, now I need to keep simplifying more. What I wrote in red, I can do more. I can apply another rule that we learned that is called the quotient rule. Every time you see a problem that looks like a fraction containing exponent, you're going to apply this rule, the quotient of a power, okay, which basically says, okay, that every time you're dividing powers with the same base, I hope you notice we're dividing 24s, those are my bases. We're going to keep the base. I'm going to keep the 24. And we're going to subtract the exponent. I'm going to take the exponent on the top, negative 34. I'm going to subtract the exponent on the bottom, that is 2. Okay? Using your calculator, that's going to be 24 to the negative 36 power. All right? And you can simplify more by applying another exponent rule, which is the negative exponent right here. And every time you have a negative exponent, you're going to do the reciprocal of the base. You're going to flip the base. Remember, 24 is like it's over 1. If you flip it, it becomes 1 over 24. And take the exponent, give it back to the 24, but positive. And this answer I have here is an equivalent expression to what you saw in question number 5. Okay? Now, we're going to do question number 6. In question number 6, we're going to do almost the same steps like I did in question number 5. Okay, let me write the problem over here. So we have parentheses 3.5 to the negative fifth power over 7 to the fourth power, all of that raised to the negative third power. So if you notice the top of the fraction, we have a power. See, 3.5 is the base, negative 5 is the exponent. On the bottom of the fraction, we have a different base, but it also has an exponent. And outside the parentheses, we have an exponent. And when you have inside the parentheses something that looks like a fraction, which is really a division, we're going back to the quotient rule. So basically, I'm going to take the top of my fraction, 3.5 to the negative fifth power, and I'm going to take all of that and raise it to the negative third power. It's like I gave the negative 3 to the top. Over the bottom, the power is 7 to the fourth power, and all of that, I'm going to raise it to the exponent that was outside the parenthesis, negative 3. It's like I gave the negative 3 to the bottom. Once you do that, now we're going to use the one that says power of power, the one I put in red. Okay, this one. And basically, that rule says every time you have a base that contains an exponent, raise another exponent, you're going to keep the base. So I'm working with this one on the top. Okay, and I'm working with this, all of this. I'm going to keep the base, 3.5. Okay, and what I'm going to do is I'm going to multiply the exponent. So negative 5 multiplied by negative 3. That will be positive 15. Use the calculator. Over. We're going to do the same thing on the bottom. 7 to the fourth power. Raise to the negative third power. Keep the base. 7. And what you're going to do with the exponent? Multiply. That will give you negative 12. Now, when you have negative exponent, you have to apply this rule over here. I'm going to put now in black this rule, the negative exponent rule. And I'm going to give you a shortcut when this happens. Every time you have a negative exponent and the base is on the bottom of the fraction, it's like you're going to take all of this and you're going to put it on the top by multiplying. Okay, that's basically what you're going to do. You're going to bring it to the top like multiplying. So on the top, I already had 3.5 to the 15th power. And now you're going to bring the 7 to the negative 12. You're going to bring it to the top next to the 3.5 to the 15th power. But now you're going to be multiplying. Why multiplying? Because before it was dividing. And when you flip, you're changing the operation. You're making division to multiplication. So 3.5 to the 15th power times 7. So I'm going to bring the 7 up. And the exponent of the 7, I'm going to make it positive. Okay? And this is the equivalent expression as the problem or question you see in problem number 6. Okay? I hope this helps.